Hey guys, Mr. Backwork here. In this video, we're going to look at rational powers of differentiable functions. So just like the power rule works for any integer values, the power rule also works for rational powers as well. So if n is any rational number, then as we're looking at doing the derivative d dx of x being raised to the nth power, then it works the exact same way that our power rule normally does, regardless of what that n value power looks like. So we drop the n value down as a multiplier, but then on that x, we subtract 1 from that power. Now, if n is less than 1, then the derivative is not going to exist at x equals 0, and we'll sort of look at why that is that way as we run through some examples. So in this example, we're going to look at using that rational power rule. So we're going to find the derivative of y equals the square root of x. Now, to use that power rule, we have to have powers in here, and it doesn't really look like we have any powers right now, but a square root can be written as a 1/2 power, so the square root of x is the same thing as x to the 1/2 power. Now if we want to find this derivative and apply that power rule, we would drop that 1/2 down as a multiplier on our x, but then we want to subtract 1 from that power. So if I subtract 1 from 1/2, then I get negative 1/2. But if I'm going to do some cleanup work here, we typically like to write things out with positive exponents. So having this negative power on this x right now, what we're actually going to do with that is take that and drop it down to the bottom of a fraction. And we've got this 1/2 happening here, so we've got that 2 in the denominator, but when we drop this x to the 1/2 down to the bottom, then that ends up on the bottom of that fraction with the 2. Now we can rewrite this because a 1/2 power means the same thing as the square root. So we can write this as 1 over 2 times the square root of x. So this is going to be our derivative for that y equation. Now this is an example where we've got a power that's less than 1. And the rule said if that starting power on your x is less than 1, then the derivative doesn't exist at 0. And here's why. Our x is now on the bottom of that fraction. So if we tried to plug 0 in for x here, the square root of 0 is 0, times 2 is 0, so we would be ending up with 0 on the bottom of this fraction, which is not allowed. You can't divide by 0. So that's why this derivative doesn't exist at the x value of 0. Taking a look at this example, now we've got y equals x to the 2/3 power. So if we're finding the derivative here, we would drop that 2/3 down as a multiplier on our x, but then we have to subtract 1 from that power. So if we have 2/3 and we subtract 1, then we get negative 1/3 as our power. Now, just like we did on the last one, we're going to clean this up by dropping this x down to the bottom of our fraction in order to make that power positive. So the denominator is now 3 times x to the positive 1/3 power. But again, I can rewrite this 1/3 power as a root. A 1/2 power is a square root, so this 1/3 power is going to be a cube root. So the derivative, if we rewrite everything, is going to be 2 over 3 cube root of x. And this is another example where our initial power was less than 1. So because our x at the very end ended up on the bottom of our fraction, this derivative does not exist at an x value of 0. Now, sometimes as we're dealing with powers, as we've seen before, we might need to involve the chain rule if we've got kind of some outer and inner functions happening. So looking at this one, we've got y equals cosine of x being raised to the negative 1/5 power. So we've got this outer function with the negative 1/5 power, but then we've got another function happening on the inside with the cosine. So because of that, when we do this derivative, we are going to have to use the chain rule. So if we start differentiating this, chain rule, we deal with the power on the outside first. So we drop that negative 1/5 down as a multiplier. We leave the thing on the inside the same. So I'm leaving the cosine of x alone for now. If I subtract 1 from the negative 1/5 power, that gives me negative 6/5 as my exponent. But now I need to multiply by the derivative of that thing that's on the inside. So the derivative of the cosine of x is negative sine of x. Now I am going to clean this up a bit here. I'm going to rearrange the multiplication that's happening. I'm going to take this negative sine of x that's on the end and bump it up to the front. So this is going to be negative 1/5 times negative sine of x times that cosine of x to the negative 6/5 power. Now in the front, when I take that negative 1/5 times that negative sine, that just turns into positive 1/5 sine of x, but then I still have this cosine of x to the negative 6/5 power on the back end. If I wanted to clean this up to get rid of that negative exponent, we can drop this down to the bottom of our fraction. Now what we've got happening in here with this 1/5, this sine is technically over 1. So the sine is going to stay on top with the 1. And 1 times sine is just going to be the sine of x. And then on bottom, we've got the 5 from that 1/5. And then if we're dropping this cosine of x down to turn that power positive, then this would become cosine of x to the positive 6/5 power. So that's going to be a simplified down version of our derivative having all positive exponents in there. That's going to be it for this video. Thanks for watching.